Hi there, it's Joe Wheaton from Utah State University. And I want to elaborate the meat of the planning process, specifically focusing on resource inventory and analysis. And so, what we get out of this phase with your newfound sort of skill set in reading riverscapes is we get to assess risks. We get to basically map and identify a snapshot of condition, and then we articulate what the recovery potential is. Whoops. So this is the collection and analysis phase, or what we call the planning phase of the overall conservation planning process that Jeremy reviewed earlier. What we're going to focus on most right now is this identification of problems and opportunities within these spaces, right? And the inventory of the resources and analysis of resource data there. We'll come back to goals and objectives in Nick Weber's talk after this. So we're in this planning part. So what part of the valley bottom is available? Well, now you know what a valley bottom is, right? We've talked about this. So we need to really get at, yeah, this is great. If I removed all anthropogenic constraints, all doses of reality, all things limiting me, the whole thing's available. This is easy, right? But our reality is usually something less than that. We're not necessarily, historic is not always a relevant target. It may be a relevant reference, but not necessarily a relevant target. So this place that you looked at earlier, where you mapped some beaver dams, is where we're going to play some games. And so if you have not already, make sure that you print out the exercise associated with this one, which is 3D, no, 3E, I apologize. So if you can print out 3E, if you need to pause, go ahead. And I'm just going to orient you here. Flow is coming in from the upper left on Upper Fall Creek and on Coburn Creek, and then goes down to Lower Fall Creek. This is the confluence. And we've got a road through here. We've got a landing strip. We've got some buildings, houses. There's stuff going on. So nice, arbitrarily selected, but realistic sort of, contrast of the types of conditions you might encounter when you show up to any old riverscape that you're going to work in. So you have your printout, get your Crayolas or pens, colored pencils, whatever you're going to use. If you want to do this on a tablet, you can. I still love the tactile nature of just doing it on paper. And I'm supposedly a GIS guy. And we're going to do a few exercises. The way this is going to work right now is I'll pause for about 5 seconds kind of after I ask you to do each piece, and that's your cue to press pause on the video and go draw, and then come back and I'll show you what I came up with, and we can compare. Okay, so what you're going to do to start is you're going to take this hillshade. This comes off of LiDAR from Open Topography that was flown for the Teton Conservation District, okay, and map the channels. We've done this earlier in the earlier exercise, and so just go ahead and start. So I'll pause right now. Okay, assuming you're hitting play. I didn't do this super carefully, but there's my little squiggly line. I drew it in PowerPoint, so I didn't digitize this properly, but good enough. So that's what I've got for Coburn Creek. This is what I've got for Upper Fall, and that's what I got for Lower Fall. Okay, so you may have, hopefully you have something broadly similar to that. Sometimes it is helpful too to flip back and forth between the aerial photo and the LiDAR hillshade in this case for context. Okay, so next up, what we want to get to is a map of the riverscape. We want to get to a map of the valley bottom. I find it's easier to map the other valley components, terraces and or fans. And here, I'll just give it away. We don't have terraces, so so go ahead. try and map the fans, if you will. I'm going to pause and let you do that. Okay, I'm going to start up here on river left. I've got this guy. One's right here. I guess I could have mapped that. I wasn't being lazy. What else we got? Another little guy there, little guy there, little guy there. Big old guy right here. Okay, that's pretty important. Now, would you have just known this from just this? You might have wanted to look at some other lines of evidence, but this is a big fan. So I also looked at the aerial photo, which gave me some hints. Another big fan down there. Then we start looking at what's coming in on this guy, and there isn't a ton. Okay, so now that you have the fans, now you're in a position to differentiate the valley margin from the valley bottom. So with a dashed dark line, please trace the valley bottom. I'll go ahead and pause. All right, so that should be enough time. I'm just going to show you what I came up with. So again, it's not drawn perfectly, but you know the hillshade does make it pretty easy. And oh, I might have lied. I think I interpreted this. It's hard without getting in the field. You know, is that a fan or is that a terrace? You can see my interpretation here is that it's a terrace. That is a good point to just sort of recognize that the precision with which you do this is not the most important thing. I'm going to just say that again. What if, you know, I mean, there's so many ways I could do this. I could do this using, you know, geoprocessing tools. I could do this in GIS. I could do this just, you know, sketching with Crayolas on a piece of paper like you are. I could do this in Google Earth. I could do this in a web browser. There's so many ways to do it. I could make it better. I can make it more precise with higher resolution data or with going out in the field and confirming these things. Don't be paralyzed by the sort of precision of this. You can get 90% of the way there with broadly, freely available stuff. You do this sort of desktop exercise, you go out in the field, and you can adjust your lines, right? If I got this wrong, fine, I move that line over. It's a start, it's a working hypothesis, and then you can refine it through time. Okay, so now you got your valley bottom, and you've also got your channel. And so what I'd like you to do next is a repeat of that earlier exercise. Map the active confining margins. And as a reminder, I would do those in pink or red. And that's anywhere where the channel is abutting the valley bottom margin. So I'll take 5 seconds, let you do that. Okay, here's what I came up with. One on river right, one on river left, another one on river left, another one on river left, another one on river left, and another one, and one on river right, another one on river right, river left, river right. Then, as we come over here, there's quite a bit, all on river right. Whoops. So what to take from this? Okay, here I'm up against a hill slope. It's also so maybe a potential source of sediment, different than the sediment I might get out of a fan. Now here I'm up against the edge of a fan, but I'm also up against this road, and those are areas that I'd want to take a careful look at. Given how long this road has been here and how regularly it's used, I doubt that this confining margin is a threat. I would guess that it's either stable or has been stabilized with some riprap. But it's the sort of thing that you'd at least flag it to look at in terms of thinking about risk. This is interesting. I don't know if I buy this as natural, especially when I see little traces like this. Um, this is a very common signature where we've taken and to make the land more useful for either farming or ranching, we realign the channel up to one side.